The purpose of this video is to go through the main concepts in ratio and proportion, and it should really help as you go through the chapter ratio and proportion on the website. So we're going to start with the first skill, which is very important to master, and that's simplifying a given ratio. So we're going to start with this one, whereby you've got 25 and then the semicolon represents ratio 36. Okay, so the ratio is between 24 and 36, and to simplify this, what we need to do is we need to find the greatest common divisor, and that's called the GCD, and you'll see that in the notes they refer to the GCD, which is the greatest common divisor, and as the name states, it's the biggest divisor. So the biggest number by which you can divide both 24 and 36. Now 24 and 36 can be divided by a number of numbers. You can divide both by 2, you can divide both by 4, but there is one number by which you can divide, and it's the biggest number. And usually to be able to find the greatest common divisor, you need to really know your times table really well. So if you know your times table really well, you'll realize that both these numbers can actually be divided by 12. So if I divide by 12 each number, so if you divide 24 by 12, you're going to get 2. And if you divide 36 by 12, you're going to get 3. So the final ratio we end up getting is 2:3. Okay, so it's all about finding the greatest common divisor and then dividing each number by that divisor. Now, what happens if you actually can't get the greatest common divisor? This is actually fine, but it actually takes more steps if you can't figure out what's the greatest common divisor. So let me just show you what I mean by this. So let's say you realize that you can divide both numbers by 2, and you start to do that. So if I divide 24 by 2, I get 12. If I divide 36 by 2, I get 18. All right, and then you keep dividing by 2. So you say, oh, I can divide both numbers by 2 again. So 12 divided by 2, 6. 18 divided by 2, 9. And now you realize that 6 and 9 can actually be divided by 3. So 3 goes into 6 2 times, and 3 goes into 9 3 times. So we end up getting 2/3, which is 2:3. All right. So if you can't find the greatest common divisor, you can actually take a divisor and keep simplifying, keep dividing till you get the simplest form. So that's another way of actually finding the ratio in very simple term. And you'll see that I've actually written the ratio in fraction form first, because another way of writing a ratio is in fraction form. So 24:36 is actually 24/36, which I've done here. And then I kept dividing by a common factor till I get the simplest one. All right, so that's how we simplify ratios. The second skill you need to have is using ratio when you're dividing. So taking a quantity and then dividing in a given ratio. And I'm going to show you that in the second example. So in the second example, what we are doing is, okay, I'm going to give you an example. So let's say we have 50 liters, okay, of paint, and we need to actually divide that 50 liters of paint in the ratio 3:2. Let's say we have 2 rooms to paint, and then we need to divide in the ratio 3:2 and then get these 2 quantities of paint, okay, which we're going to use for the different rooms. So I'm going to use 3 of the parts for room 1 and then 2 of the parts for room 2, let's say. So every time you have to divide a quantity in a given ratio, what you need to do is you first need to find the total number of parts. Okay, so total number of parts You get it actually by adding the two numbers in the given ratio. So 3 plus 2 is equal to 5. That's the total number of parts. Now I've got 50 liters which I need to divide into 5 parts. So I get 10 as one part. Okay, so that's just proportion. So 5 parts is equivalent to 50 liters. I need to find for one part, so that's 50 divided by 5, which is 10 liters. So one part is 10 liters. Now the ratio is 3:2. And let's say 3 parts is for room 1 and 2 parts is for room 2. So one part represents 10 liters. For room 1 we need 3 parts, so that's 3 times 10. And for room 2 we need 2 parts, that's 2 times 10, because one part represents 10 liters. So we end up getting 30 to 20, which means that the 50 liters was divided into 30 liters and 20 liters. So room 1 is going to get 30 liters of paint, and room 2 is going to get 20 liters of paint, and that's how we're going to split it. All right. So the first example we've done so far was about just simplifying a given ratio. In the second one, it was put in a context. We had a quantity which we had to divide. So here it was about paint being split in a given ratio so that we can paint 2 different rooms. But the example can be, take any given context. You could be sharing money, you could be sharing objects, it can be anything. Now, the third example we're going to explore is a mapping example. So we have a map whereby the scale is 1:50,000 centimeters. Okay, so what that means is that 1 centimeter on the map, okay, is equivalent to 50,000 centimeters in real life. Okay, and this is quite a common example. And the question is that what does 8 centimeters on the map represents in real life? So that's another example whereby we've got not ratio but proportion involved. So you can see that 1 is becoming 8, so I'm multiplying by 8 on the left hand side. So what I need to do is I need to multiply by 8 on the right hand side. So I end up getting 8 times 50,000 centimeters. And if you multiply that, 8 times 5 is 40. So you end up getting 400,000 centimeters. All right, 8 times 5 is 40, and then we had 1, 2, 3, 4, 4 zeros. Okay, so 4 zeros is here, and then 8 times 5, 40. So 8 centimeters on the map is equivalent to 400,000 centimeters. Now, if we need to give the answer in kilometers, because in real life we don't really use centimeters, isn't it? If we need to find the distance between two given places. So what we need to do is we need to convert centimeters to kilometers. So what's the link between kilometers and centimeters? So I know that 1 kilometer is 1,000 meters, okay? And to convert meters to centimeters, 1 meter is 100 centimeters, so it's 1,000 times 100, which is 100,000 centimeters. Okay, so 1 kilometer is 100,000 centimeters. So if you need to move from kilometer to centimeter, you multiply by 100,000. If you need to move from centimeter to kilometer, you need to divide by 100,000. So to convert this to kilometers, I need to divide by 100,000. And if we divide, we end up getting 4 kilometers. So this will be the final answer. And if it's not really clear what happened here, I can go back to this. So 100,000 centimeters is equivalent to 1 kilometer from the workings I just showed on the left hand side. So now we need to work out what's the equivalence of 400,000 centimeters. So 100,000 is becoming 400. You're multiplying by 4. So if you use proportion, 1 times 4 is 4. So 400,000 centimeters is equivalent to 4 kilometers. So there are a couple of different ways of actually viewing this question. Okay, I hope that this video gave you an oversight of the key skills needed for the chapter ratio and proportion. And these videos really should accompany the notes which you have on the website. And once you've viewed the video, you've gone through the notes, you should be able to do the 2 questions. Two sections on the notes workbook. You have a section on the core section of that chapter, and then a section on the extended section of the syllabus, and you need to do both of them. All right, so good luck with that.